This is the CAD work for the V1.0DexHand, which was kind of finished over stages, but was shown at CES at the start of 2023. So I'm treating this one as the release version. And what's presently on the GitHub is Hand 06 and this is Hand 07. But all of the internal components appear to be the same. So I think it will do, and it will also iterate the numbers, which is important because keeping track of all the versions is not straightforward. Now I see it's got the modifications on the thumb, but I have now found in fact one error. There's a mistake here. That hole should be over the top of that hole. And by hand I added some plastics and polymorph to guide the wrist and also the tendons down in the forearm. Where is it, that one? No, that's the wrong one. And of course some of these details are incorrect. None of the PTFE is shown, none of the wires are shown. But you can at least see the wrist mechanism here. There are two servos which are arranged so that effectively the tendon crosses over. So it actuates the corners. This corner here and this corner here are driven by a single servo. This corner here and here are driven by another. Oh, I've got the cover as well. There we go, that's better. There we go, you can see it there. Now, this tendon actually goes all the way round, back out, and down there, and then one loop of it pokes up through one of these holes and is secured off. They also then continue through these gaps and on to the relevant palm bone, shall we say. So the orange stops here because it's, I guess, just too complicated to model it simply whilst the hand is moving. But nonetheless, this orange tendon continues up through here, over the top of that. Looking at it, I think they probably cross over actually. It's been a good long while since I've made one of these. Yes, it does. Okay, so it comes here, goes down through that hole, comes out on the other side, goes down through that hole, loops around a screw here, and then goes back down through that hole, out of here, and then in the other way. So in fact, the wrist tendon is a single long piece, which does the whole route. And then from memory, it's on this one that they can be secured. So on this one, you simply have a loop, which is clamped off, but on this one, the loose ends finally emerge, and they get clamped around the center, because it's more accessible than the other one. Constructing the forearm is also quite tricky, because there are inserts required to be removed in order to get these servos in, and that's a concern, but that's in the wrong place because it means that the model is slightly corrupted. Oh no, what's that? Oh no, that's another servo. Let's hide that. Okay, that's better. Right, yes, I remember now. Okay, so the two servos I just made vanish are slightly larger. These are the Emax EX33s, which are only 9mm thick. And I thought they'd be a little bit underpowered. So I ended up using a normal thickness micro servo. And there you can see how much larger it is. And they also happen to be serial servos. The serial servos produced by PETG, which gives you greater range of motion. So one of the issues I'm having is that the V1 is a little bit experimental, so to define just one version of it, it's actually quite tricky. So on this side you can see that there was in fact enough space to make the wrist motors larger. And on this side it looks like it hits, so I wonder if I made a mod. It's not that one, is it? Oh yes, it is. It's the top one. Okay. Let's put that back. That's the battery cover we weren't using. I think I just made the whole forearm disappear. Yes. We are doing a mega. Okay. So yes, there is enough space. Actually, there's a tiny clash there. But these models of the servos, are slightly larger than the real things, and they don't include some of the end chamfers. So that will still fit, and it did fit because I used these larger servos in the V1 that I made. You can use either. Servos is a choice often of cost, but also of simplicity of use. The ES33 series are standard legacy servos, so you can plug them into any radio gear or any other project you've ever run servos on, and they work. The PETG serial servos require a different adapter board and an Arduino running code and are a little bit more involved as a result. But you know, there's a natural progression in these things. That at least shows you some of the internal layout. So if I put the bulk back, and I'll make the whole lot transparent. I'm not sure that really helps. No, maybe it doesn't. Let's keep it normal. So what may cause some confusion as well are these additional pieces, and there are 3 inserts. Let's hide that one, and hide that one. Why are you still there? There you go. And there's one here by itself. So that is the first insert which goes in when, let's remove this. The pulley and the bearing. Okay, so the support for this servo is an insert, which is that insert highlighted in blue. So the small insert is screwed through this hole and will retain this servo on one side. When the other servos are added above it, these then fit around them, and in fact this servo here has to be screwed on first, because screw is accessed from the other side. No, no, actually this one goes in the back. Oh no, there's something you have to do about this one to assemble it. I don't remember. So when I take the other one to pieces to show you in the real thing, which I will do, soon, I hope. I might try this afternoon, but then I'll leave everything in pieces. That's a little bit involved, how you put all that together. But it ends up like that. So with a bit of trial and error, you should be able to work it out. But it doesn't help too much. There's holes here as well, which can take steel pins, because the PTFE will come in through the wrist. So if you remember from assembling with fingers, you've got PTFE emerging from these channels here. There's one in each of the palm bones, and the PTFE then has to pass through the wrist along with the 8 cables for these servos. And it's important to remember that this servo will be slightly too short. The cable for this servo will be slightly too short. So I've extended mine by soldering on some short extra bits of wire, and I tend to do it up in the hand because space is very tight as you get down to the forearm. So we open up the wrist, have a look. Actually, that's true. The naming convention is wrong. When I was designing the wrist, I ended up flipping it round. So what's called the distal wrist is actually the proximal wrist. I will, I think, change it when I do the GitHub update. So the proximal wrist, yes, that's incorrect. Anyway, so we can get rid. Okay, we can hide that, which is what passes the wrist tendons, and we can hide one of the solid bodies. Which one's it going to be? That one. Okay. And then one more layer. This is a removable part of the proximal wrist. And you can see the inside of the wrist now. So the PTFE, which contains the long tendons which actuate the fingers, they come out of these channels and then they pass between this central support and the gap in this part of the wrist, which is itself removable, I think. Yes, which is the central part of the wrist. So they pass through that, and then they're going to pass over the top of these pins, which then allows you to connect the tendons to the servo horns. Now, in the CAD model, these are not the actual servo horns, these are clearances. The servo horns are smaller than that. And there are some which are there are 4 which are easy to get to, which are up here, and there are 4 which are harder to get to, and they're down here with 2 wrist motors sandwiched amongst them. You didn't think it was going to be easy, did you? But that is how the long tendons of the thumb and the fingers are connected. In the V1 there are 8 motors up in the palm itself which drive the knuckles of the fingers, but all of the actuation for the thumb is done down in the forearm, and the long tendons are also all driven down the forearm. I tend to use these 4 for the fingers and these deep 4 for the thumb, but thinking about it, there may be better ways of doing it, particularly for thermal concerns, although the V1 is not really rated to run continuously. Something to be aware of when you first start to assemble the forearm is all of the electrical cables have to pass out backwards through this window into this compartment if you're planning to make a completely sealed up V1. So before any of this goes in, you need to lay out the hand and the wrist, pass all the electrical cables through this gap, and then in the channels which exist at the bottom and in the sides, and I think on the V1 in fact it's all mainly through the sides, there's a gap here provided so that electrical cables can come in round this round that chamfer there, round that clearance, into the sides, and then as they travel down inside the forearm they splay back out, pass through a tunnel which is provided here. No, not that tunnel, where is it? There's another one. Oh, there's a tunnel in this section. Hang on a second, how do I show you that? Let's hide that. Yes, no, one more to go. There it is. So the servo wires will pass through the wrist in these side channels and end up going out through this hole here. Underneath the wrist servo, which is a circular servo horn, and then out through this window, at the back. And in this compartment there is enough room to put all of the electronics required to drive it, either as legacy relay control servos or with the serial extra for the wrist, and a receiver for an XP, and a receiver for an S-bus, and 2 batteries, and a power converter, and an Arduino Mega. It's a fair amount of electronics packed into a very small area. That will come later. And here we see on this side, this is the large wrist rotator, which can be a standard 40mm servo. That's what I can do quickly, folks, while I'm on holiday. Oh yes, there will be some mods for this, by the way, as well. So I will fix this, I will modify that. What else did I miss? Oh yes, the wrist. There's one more mechanism in the wrist. So the wrist is driven by these 4 tendons on the outside, which are in fact arranged in pairs. But because it has 2 pitch joints, there's one pitch joint here and there's one pitch joint there, there's an instability. It's exactly the same as the fingers. There's not enough driven degrees of freedom to contain all of the freedoms in the structure. And I use exactly the same solution. There is a figure 8 ligament which connects using these channels in the middle finger, palm bone, and they anchor back to screws, which are mounted here in this bulkhead back in the forearm. The complication is that the wrist joint also has a yaw rotation. The hand, let me see if I can make it move. Yes, it should do. The hand can also go from side to side like this. And you can see that this hole through the center of rotation stays constant. So in addition to the figure 8, there is also a constraint, which means that the crossover of the figure 8 passes down inside, as near as possible, the center of rotation of the wrist joint itself. And for that reason, there are bearings, 2 on top and 2 on the bottom, which all the wrist stuff's been deleted, all the wrist stuff's been hidden, but I can put it back. That's the middle section, that's the top section. Let me show it clear. Let's go to this one. Okay, there we go. So, yes, okay, so the wrist figure 8 ligament, the crossover of the figure 8 is forced to go, I guess you'd say that was horizontal, vertical, depending on your point of view, is forced, the crossover of the figure 8 is forced to go through this hole, and on this side it comes up to a single bearing, which is mounted here, and then passes out through this hole, that hole there, and onto the palm bone. And on the external, on the other side, there are 2 bearings, because that hole is here and it comes up. There's one bearing mounted in here, and there's one bearing mounted in there, and they then pass to this bulkhead of the forearm. They cross over behind, as always, to make sure that the tendon always runs over this circular surface. And when one from the top comes out the bottom, it goes through, and there's actually a hole to be added here, because it's very awkward. But there is a hole which passes back from there, and it links up to this hole here. So what I would advise you to do now, until I've corrected the files, if you've already printed these, is just drill this hole out. Just, maybe it's this one actually, think about it. Must be the back one. I'm sorry, it's so long since I made this. And then you'll be able to see, when the tendon comes in the bottom, you'll be able to see the tendon and pull it up. It comes up to here, one in the top, which of course is one from the back, has gone through and up and out, and then they can then be clamped in here. So in fact I will generate some, I'll try and do some video, I'll take some film today, and then I'll try and edit it together to at least show some of these surface details. Okay, so that's the CAD. And you'll notice that there are a lot of clearance holes left for accessing screws. I think those are all complete. I think you can access everything. Still, fiddly business assembling a robot hand. If you've made a start, that's really great. And just keep going. And I will keep trying to get instructions out to explain how to do it. So keep comments coming. And any suggestions. I will, when I've assembled the new one, do an introductory video where I'll try and explain as much as possible. So anything which has vexed you or irked you along the way when you finally realise what it is, please tell me. Put it in the comments and I'll try and include it in the part 1 video, which will introduce the series. And then we'll also think about other ways to get people involved. Okay. Bye for now. Merry Christmas and a Happy New Year.